The workflow that we use at the Bureau of Economic Geology has for a long time focused on the 𝗕𝗿𝗀𝗁 software, for which we have received a very nice donation from 𝗕𝗏𝗁, and we have a lot of users for that. But it needed to be augmented with some more advanced seismic interpretation capabilities. So what I'm showing you right here is basically the top 3 products which we can no longer live without in all of our subsurface studies. And that is the 𝗕𝗿𝗁𝗆, Paradise, and 𝗕LEOscan. So all of these things kind of came together over the last couple of decades and years, and I decided about 5 years ago that we needed to build a 3-dimensional model of the entire Permian Basin. And after several years of building a Permian Basin model, I asked myself, okay, well, are we close enough to being able to match this excellent work done by geologists for this 2-dimensional cross-section with the contribution of many, many people at the time? So that's what we'll touch upon a little bit later in this presentation. But within the Permian Basin, one of the things that we focused the Paradise technology on is fault identification as well as lithofacies prediction. We effectively used all of the data that we can license from the industry, that we can get donated from various oil companies, that of course we have in our over 100 years of history at the Bureau of Economic Geology. And over the last 5 years, we've been integrating all of that data together into one place. So what do we have? We have approximately 360,000 wells that contains stratigraphy data. And that's, of course, the well log tops that we use in order to build the zonation throughout the Permian Basin. Right? Then we have well log data. And also with the help of our collaborators in the TextNet group, we've been able to get our hands on quite a bit of data that we use for petrophysical calculations. And this particular slide shows 7,000 of the highest quality quad combo wells, as we call them, with all the various well logs in it that we need in order to calculate high quality petrophysical data, such as porosity, water saturation, and permeability. And then the tops I was talking about earlier in those 360,000 wells result in approximately 3.2 million tops for the whole basin. Then, through the very generous donation of seismic volumes from a wide variety of oil companies that do joint research with the Jackson School, we've been able to bring approximately 38 3-dimensional surveys and over 2,500 regional 2D lines, all within the same project. More detailed models we've incorporated as well, such as a field in the Midland Basin, generously donated by the Fasken Oil and Ranch Company, right? So the whole idea is that we don't just do the research on the regional model, we link in high resolution field models. And here's what the model looks like when it's cut at the famous Wolfcamp interval across the Permian Basin. And one of the initial purposes of this model was to build a 3-dimensional velocity model, mainly for the TextNet group, for the main purpose of doing the time depth conversion of the seismic volumes, as well as for the very important earthquakes associated with the saltwater disposal that Mark Schuster mentioned in his intro. So I pulled it in, and this is what I got. I'll let you be the judge. But overall, you can see that we now are capable to make a cross-section for an entire 2.4 billion cell model where we can move the cross-section anywhere we want, right? And then still validate it using the very famous West Texas Geological Society cross-section. And here is an overview of the Permian Basin with green polygons representing the 3D seismic data. The black dots represent all of the well logs for which we have enough high quality raw data in order for us to be able to calculate petrophysical data. So those are the 2 main inputs for any Paradise lithofacies prediction model. You need well logs with petrophysical data, you need core data, and you need the 3D seismic data. Right? We for every single one of these green areas, we are combining the petrophysical data with the seismic data in order to calculate facies predictions. And the facies predictions will then go into 3-dimensional models with layering structures. Those colors that you see on the well logs right there, those are the high resolution petrophysical multi-mineral calculations. And all of that is used to build a 3-dimensional model. And then apart from building 3-dimensional velocity models, we go further and further downstream in the direction of the engineering. So we integrate all of the production data that you can see right here for the Wolfcamp, all of the horizontal well trajectories with landing zones, estimated ultimate recovery for water, liquids, water cuts, oil production, so on and so forth. So The model also functions as a basis for reserve estimations as well as for investigations related to well productivity and facies distributions.